Hi there. Wanted to quickly talk about two intelligent query processing features that are available to us in SQL Server 2022. The first one is Parameter Sensitive Plan Optimization, or PSPO. Either way, it's a mouthful to say, but it's for a really common problem we probably all see daily. This is that problem that we have when we run a store procedure for one parameter, it works great. But when we run it with a different value, it works horribly because our data is skewed and the plan we need for that second value is not the same one we need for the first. This is an attempt to try to help us solve those problems. The second one is memory grant feedback persistence. Now, I know what you're thinking. This existed in SQL Server 2017 and 2019. What are we talking about with 2022? It's that persistent piece. That's kind of a key thing. And it's a cool thing we can use to help identify problems that we have with memory grant. Don't believe me? Here, let me show you what this all looks like. I'm going to switch over to my SQL Server instance here. We're going to use the wide world importers. We're going to start looking with the parameter sniffing, the plan sensitive plan optimization. The first thing I'm going to do is I'm going to make sure I'm in the previous compatibility level 150 or SQL Server 2019. I'm going to clear out procedure cache, I'm going to clear out query store, and I'm going to rebuild one of my indexes just to make sure. Now that that's done, I'm going to say what I want the plans to look like to begin with. So we have these two queries here. So we have our select from order lines. We're selecting several columns from there, and then I'm going to get the supplier name from the suppliers table. So I'm joining through my stock items ID. And I'm searching based on my supplier ID, and we're looking at 2, and we're looking at 4. So now that these queries have run, let's see what these look like. I'm going to look at my execution plans over here. My first one, we can see that it's doing an index, it's joining stock item and order lines, and then it's doing a nested loop join to our supplier table. It's optimal for that query. So if we look over here, moving over here, we can see that we have that our second query is doing something different. We have a clustered it's joining our supply and the stock items, and then it's doing a hash match to our order lines. So it's a very different query that we're looking at, but it's a different type of join. Now, what happens when I put all of this into a stored procedure? We have a very simple stored procedure here, create or alter, and it's the same select statement. I'm just putting everything into a parameter. So when I run these two side by side, and I look at my execution plan, well, first of all, first problem, it's still taking, it hasn't finished yet. So let's give it another couple seconds. Let everything finish. 15 seconds. That's longer than it took that first time, remember? So if I look at the execution plan, the first one's as expected. I have that nested loop join to the supply table after joining stock and items and order lines together. Now, if I come down to the second one, we can see it's the same query as the first one. It's a nested loop to the supplier after joining stock and the stock items and order lines together. It's the wrong query, which explains why it took so much longer for everything to come together. Now, I'm going to change my compatibility level to 160. I'm going to clear my procedure cache, and I'm going to clear out query store just to be sure. So that's set. Now I'm going to, without making a change to my store procedure, I'm going to run it as is. And when I look at my execution plans, we can see the first one is what I'd expect it to be. We have a nested loop to our supplier after the join to stock items and order lines. That's what we'd want. So what happens for our second query? Let's scroll down. Oh, hey, look at that. It's doing stock item and suppliers first, and then a hash match to my order lines. That's the query plan we wanted. This was the optimal query. All I did was set it to SQL Server 2022. And yes, my database setting for parameter sensitive plan optimization is set on, and we can tell because it's working here. If you don't like it, you technically can turn it off. But let's take a look at Query Store because we have some extra information here. So we have our SQL text. We can see the query plan is the same. But we also notice something else here. We have a plan type 2. It's saying it's a query variant. So if I open my execution plan, so we have a little bit of a better look, we notice something different if we go to the statement. And if I scroll in here, zoom in here, we notice that there's been an addition made to our SQL text. It's adding an option, and what it's doing is saying, please use this query variant. So what SQL Server does is when it notices this SKU, it will break things into buckets, a small, medium, and large bucket. And based on the distribution, it'll figure out which one of those three it should belong to. Now, we don't have a lot of variants because if we had a variant for every single parameter that's being passed in, well, parameters don't help us anymore. Plus, we'll have plan, plan cache bloat, which is its own problem. So we still need to have some reuse. And it's not going to solve all of the problems because of the way those buckets work. But in our case, that bucket absolutely helped us get the right plan because it said which query variant we wanted it to use. If I go back to my query store, I want to point out two other things. We noticed when we looked at the statement that's with our execution plan, the text had changed. It also means that it's essentially being executed as a different query text, and it's logging it as a different query. But the other part to note is that object name, it's now null. When I originally tried writing this query, I tried searching for the object name. It's a store procedure. I should know what that looks like. But because of that SQL text change to say which option, which query variant it should use, it's no longer associated with that store procedure in Query Store. We absolutely have access to it, and while it would just require a little bit of extra work to associate with our original store procedure, but all the information we need is right here. And this is something that we have happen all the time. Parameter sniffing is a very common problem. This may not be able to solve all of our problems, but it's certainly helped us in this one. And when I feel like I shouldn't say that it doesn't work in all scenarios. If you look at the documentation, there is definitely some scenarios that it doesn't do. It doesn't do range scans, and there are a couple other problems that it can't quite solve all the problems for. In fact, when I originally tried putting this demo together, I thought I had a great case for SKU, and I thought I had a great case, and I was so excited for PSPO to kick in and work, and I was a little disappointed it didn't. But it did show another problem that we are able to fix as part of SQL Server 2022. And it's not just fix, but also track. And I think that's kind of the key thing, the ability to track. And it was a memory grant problem. So let's switch over. The first thing I did is I turned off memory grant feedback persistent. This is that new configuration to say use memory grant feedback persistent. I want to show the old behavior first. And make sure we're on the old behavior first, at least so we can see what the differences are. So my issue, I started off by, I wanted to look at package types on my order lines because not everything's going to be the same package type. Maybe one is more than the other. And so when I ran this and I looked at my data, I noticed package type 1, only 1,000 values, but 7 had a lot more, just under 221,000 records. That felt like a pretty good SKU, right? That should kick in, or so I thought. So I created my store procedure, and I was super excited to see what happens when I ran everything. And so I ran it. Takes a couple seconds because the data is still skewed. It's a little different. And so now that it's run, I went to look at my execution plan, and I was sad because we looked and we saw that they were the same. Both of them use a hash match. But the second one, I have a warning sign, and when I look at that warning, it says operator used tempdb to spill data. Granted, and it looks like it's a memory grant issue. Oftentimes when I see those warnings, that's what's going on. I'm getting a tempdb spill, memory grant. So let's take a look at that. I'm going to solve that the same way I would with 2017 and 2019. I'm going to run it 5 times. And when it does, and when SQL Server works on these changes and it does those memory grant feedbacks, it usually used the last value that was needed for memory grant and then go from there. So that's what it did here. And if I look at my queries, the results, the first one, yep, it still has tempdb spill, still has the warning sign, still has the warning sign. Aha, we don't have a tempdb spill for 4 or 5. But does that mean that memory grant's been solved? Did we come up with a conclusion? If I go to my properties, well, no, it hasn't, but it's still adjusting percentile. So it's been going through the changes and it's been resetting. And if I go to 5 and I go to memory grant, yep, it's still adjusting. So it hasn't figured out where it needs to be yet. Now what happens if, now that I've done that, I go back, I run these two again. What happens here? If I look at my execution, well, again, I don't have a tempdb spill, but memory grant for 1, it's adjusting, still adjusting. 2, memory grant. Yep, it's still adjusting. So we haven't quite figured out the right thing, and I'm putting different values in, but it's using the previous value to try to figure out what it should be from here. All right, so we haven't quite solved it. And when we clear our procedure cache, what happens? Takes a couple seconds, taking a little longer. There's my execution plan. Go over to my memory grant info. Procedure cache is cleared. We're back to our first execution. We got to go all over again, restart everything. All right. Now let's talk a little bit about what happens if we set memory grant feedback persistent on. So now this is that new setting with SQL Server 2022. So the procedures run. I'm not having tempdb spill, at least, or at least it's not showing as such. But if I go to memory grant info, it's the first execution. So I'm going to run this. Let's run this 5 times. It'll take a couple seconds and we'll see how things look. So if I go here, let's take a look at our select memory grant. Unfortunately, it doesn't stay open, but memory grant feedback is adjusting. 9216 here, query 2, memory grant. Ooh, it's stable, 9216. It likes what it saw. And if I go down, let's look at some of these other queries. Let's jump down to the 5th time, memory grant. It is still table desired memory 9216. So the cool thing is it didn't find that stable version earlier, but it did found it quickly here. Now let's take a look at our query store because nothing's changed, and this is a similar query to what I looked at previously. We do notice that we have our query ID, we have that number of things compiled, but we do notice starting to notice a change. There's a new plan ID for these last two rows. And we can start seeing things. We can see the average memory, but we also see this new information, memory grant feedback. And now we have feedback data. So we can now see that what SQL Server is keeping track that, hey, I had to do some memory grant adjustment here. And we can track which queries that have that problem. Now, I've tried looking at this before because I was trying to show a demo and I was trying to go through my query plans. This is really hard to find in Query Store after the fact and going through data. I don't have to do that. I can just look at my Query Store. There is a new DMV called Query Store Plan Feedback. And this information is not just about memory grant feedback, it'll also contain information if you're doing things like the cardinality estimation feedback or the degree of parallelism feedback, which both of those are pretty hard to identify, diagnose, and let alone find the fix for. Now we have feedback connected with Query Store so we can find when those pieces of information happen, we can go back and look at it. More importantly, SQL Server is going to be using this feedback information and make sure that it can stabilize the data, especially as it's making adjustments. Because if it makes an adjustment too far, it has what it was when it actually worked. And so now it's stored that information and says, hey, I adjusted the memory. I went a little too far. Can I pull it back? This is my last known good value. I've averaged it out. And because it's figured that out, it makes it easier for SQL Server to maintain that value and persist those values and reuse those. So when you originally had the problem, you're not going to have it the next time you run that plan. Is this going to fix all the problems? I never say anything is. Where DBAs, it all depends. But is it going to give us more information than what we had before? I believe so. And all of these parameter sniffing, memory grant feedback, these are things we see every day, I think, as DBAs. And we see these all the time in our databases. Being able to have these are really useful tools for solving long-term problems. Would I put this out in production immediately? Of course not. I'm going to put it in dev, I'm going to put it in QA, and I'm going to test my workloads, and I'm going to find that information. But I have that information. And that's the key thing. And I think that's going to go a long way to helping solve a lot of our performance issues. So these are just two of the features that we have with intelligent query processing in SQL 2022. I'm looking forward to playing with them a lot more in my workload and see what it can tell me and seeing how it can help me improve my performance. I hope you find these useful, and I hope you find that they help you with your issues as well. Thanks. Have a good one.